Okay, so good morning all of you. In today's session of SHM, we are going to discuss some applications of SHM. I think the focus will be mainly on topics like gravitation, rotation and circular motion. So there is a question that there is a tunnel which cuts across diametrically through the center of the earth. So there's a tunnel which has been dug straight across the diameter of the earth, and there is a particle. Okay, there is a particle, and that particle is released in this tunnel, and it is undergoing simple harmonic motion. Okay, the particle is undergoing simple harmonic motion. So you have to calculate the time period. Okay, so there's a tunnel and a particle is undergoing simple harmonic motion. You have to calculate the time period. So first thing what you have to do is that this particle is undergoing simple harmonic motion. That means at any point of time the particle will be somewhere inside the tunnel. So the place where it is located, suppose the radius is x. So what will be the mass of this dotted sphere? It will be 4/3 pi x cube divided by 4/3 pi r cube into the mass of the whole sphere. So 4/3 pi x cube by 4/3 pi r cube into the mass of the whole sphere. So that is coming x by r whole cube into mass of the whole sphere. Okay. Now, so this will have a gravitational attraction on the particle. Suppose the particle's mass is m. So the gravitational attraction will be, this is the mass of the dotted sphere into the mass of the particle divided by x square. So ultimately it is coming g into capital M into small m by r cube into x. So this is the mass of the dotted sphere. So the mass of the dotted sphere into the mass of the particle is small m into g by x square. So g into capital M into small m into x by r cube. Now this is the gravitational force. Now in this formula of gravitational force, this is the part which is playing the role of the force constant k. So the time period will be 2 pi root m by k. So the time period will be 2 pi root m by k. So that is 2 pi root r cube by gm. So that means that it will undergo SHM of time period 2 pi root r cube by gm, right? So once again, this is actually a very iconic question. It is there in many books of physics. So the tunnel goes straight through the center of the earth. So it is diametrically cutting across the earth, and the particle is undergoing simple harmonic motion. You have to find the time period. So what we are doing is we are saying that you consider a dotted sphere of radius x. So the mass of the sphere will be 4/3 pi x cube by the mass of the whole sphere is 4/3 pi r cube, and into mass of the whole sphere is capital M. So x by r whole cube into capital M, and the particle's mass is small m. So g into the mass of the dotted sphere into the mass of the particle by x square. So g capital M small m by r cube into x. So force is equal to force constant into x. So 2 pi root m by k, if you do, you will get 2 pi root r cube by g. So this will be the answer. Okay, now let's have a look at another application of SHM. Okay, now let's have a look at this question. Simple pendulum undergoes small oscillations with amplitude theta 0. Find the tension as a function of the angular displacement theta. And the second part of the question is that when will the tension be maximum or minimum? Okay, so let's understand that this is the extreme position. Okay, and amplitude is theta 0 and this one is theta. Okay, so what we can do is that over here the kinetic energy will be 0 and over here the kinetic energy will be half mv square. So by conservation of energy, we can say that half mv square will be equal to the change in potential energy between these two locations. So half mv square will be equal to the change in potential energy between these two locations. So change in potential energy between these two locations is mgl into cos theta minus cos theta 0. This will be the value. And suppose the tension is T. So T minus mg cos theta is mv square by L. So T minus mg cos theta is 2mg into cos theta minus cos theta 0. So T is 3mg minus 2mg cos theta 0. So once again, let us discuss. So this is not really much of simple harmonic motion analysis is being done. This is more like a circular motion sum. So the kinetic energy over here is 0, here the kinetic energy is half mv square. So this should be equal to the difference of potential energy between these two positions. So mgl into cos theta minus cos theta 0. Now the tension in the string is T. So T minus mg cos theta will be mv square by L. That means tension minus mg cos theta will be centripetal force mv square by L. So in this mv square you can replace from here. So T minus mg cos theta is 2mg into cos theta minus cos theta 0. So T is 3mg cos theta minus 2mg cos theta 0. So this is the answer for tension. Now the second part of the question is that when will the tension be maximum and when will it be minimum? So obviously maximum will happen when theta becomes 0, because that's the maximum value of cos theta, and minimum will happen when theta is theta 0. Actually you can say plus minus theta 0. So once again, the first part is that when is the tension maximum? So obviously theta will be 0, minimum theta will be plus minus theta 0. So this is how you can do application of simple harmonic motion in SHM or application of simple harmonic motion in gravitation. Okay, the first homework question is that there is a rough concave surface of radius capital R and there is a ball of mass small m and radius small r. This is a rough concave surface. So it is performing small oscillations. You have to find the time period. Okay, this is the first question. Question number 1. Okay, the next question is that a pendulum has got a length of 40 centimeter. This pendulum is taken inside a deep mine. Okay, this pendulum length is 40 centimeter. It is taken inside a deep mine of depth 1600 kilometer and radius of the earth is 6400 kilometer. The question is that what will be the time period of this pendulum? Okay. So the length of the pendulum is 40, it's taken inside a deep mine of depth 1600, radius of earth is 6400, question 6400 kilometer. So question is what will be the time period when it is taken to the deep mine? Okay, then we come to question number 3 of the homework. So in question number 3, the question is that there is as usual that same tunnel question. So there's a tunnel dug across the earth passing through the center of the earth. So there are 3 situations, situation 1, situation 2, situation 3. For each situation you will have to find the time period. Situation 1, a particle is projected with a velocity root over small g into capital R. Okay, small g into capital R. It is projected with this velocity root over small g into capital R. It is projected inside the tunnel. That is situation 1. Situation 2, the particle is released from a height capital R above the surface of the earth with initial velocity 0. So from a height capital R above the surface of the earth, it is released with an initial velocity 0. What is the time period? And situation 3, it is released from the surface of the earth but upwards with velocity root over g into capital R. So 3 situations are there: root over g into capital R projected inside the tunnel, then release from a height capital R above the surface of the earth with a velocity 0, and situation 3, projected vertically upward with velocity root over small g into capital R. For each of these 3 situations you have to find the time period. This is homework question number 3. Okay, question number 4 of the homework. Question number 4 of the homework. There is a tunnel. Whose position from center of the earth is radius by 2. So the radius of the earth is capital R, and there is a tunnel whose position from the center of the earth is radius by 2. Now, in this tunnel, and the radius of the earth is capital R. In this tunnel, there is a particle which has been released, and the distance of the particle from the center of the tunnel is x. So, the tunnel is at a distance of r by 2 from the center. The radius of the earth is r. In this tunnel, there is a particle whose distance from the center is x. So, the first thing you have to do, question number 1, you have to find the gravitational force on this particle. That is question number 1. You have to find the gravitational force on this particle. You have to find F. The second is you have to find the component of F both perpendicular to the tunnel and along the tunnel. So once again, part 1, find the gravitational force F. Part 2, find the component of F perpendicular to the tunnel and along the tunnel both. Part 3, find the normal force of the tunnel wall on the particle. So this tunnel wall is exerting a normal force on the particle. So find the normal force of the wall on the particle. Part 4, find the resultant force on this particle. Resultant force will be due to the F and due to the normal. What is the resultant force on the particle? And part 5, this particle will execute SHM in the tunnel. Find the time period. So these are the subparts of question number 4. Okay, there is a pendulum. It is inside an elevator. The length of the pendulum string is L. There is a pendulum. The length of the pendulum string is L. The pendulum is inside an elevator. So the first question is find the time period of the pendulum. Okay, that is the first question. Find the time period. Second is find the time period if the elevator is going up with an acceleration a0. Find the time period if the elevator is going down with an acceleration a0. Find the time period if the elevator is going with uniform velocity. So these are the 3 questions of question number 5. Find the time period of the pendulum of length L inside an elevator. If elevator is going up with a0, elevator going down with a0, elevator is going with uniform velocity. So these are the 5 homework questions related to SHM applications. Okay, and you will have to submit the homework by 9 p.m. tomorrow. That is 9 p.m. of Tuesday. So that will be all for this session. I will conclude the session. Bye all of you.